So, I think we can begin. Thank you very much to be here. My name is Horacio Gonzalez. As you can maybe hear, I am a Spaniard and I live in France. So my English accent is the combination of two of the worst accents speaking English. I am sorry about that. I hope it doesn't bother you too much. I work at OVH, a hosting and cloud company. Who here knows OVH? Not many. We are the biggest European hosting and cloud provider. We are maybe the 5th in the world. We are way smaller than our friends of Google, Azure, or Alibaba, but we are playing in the same field, and we have a lot of products, and we have very interesting prices. So next time you have an application to deploy, an infrastructure to mount, please go to our site. I think you will be surprised, and maybe you will find a new way to host your products. So I'm here to speak about Kubernetes, and to speak about Kubernetes in a production setting, not only the developer part of Kubernetes, but what to do after you, as a developer, has successfully deployed your applications on Kubernetes. Who here has already done something with Kubernetes? Hey, it's better. First time I did this talk 6 months ago, it was almost 10% of the room that has touched Kubernetes. Who here has put something on Kubernetes in production? You see, that's why I think this kind of talk is important. Who here doesn't know Kubernetes or only some concepts? 1, 2, 3. Oh, better and better. I am going to do a small introduction on Kubernetes to put everybody more or less in the same level, and then we can go further. So why Kubernetes? Yeah, but let's begin with a bit of history. I like telling stories at the beginning of my talk. So I am already a bit old. When I began doing computer things, everything was based on physical computers. You bought computers, you put them in a rack, you install an operative system, and then some sysadmin teams were going to deploy the applications one by one on those servers. It was nice. It wasn't agile. If you needed to deploy more instances, it was complicated, manual. So several times after I had begun, the virtualization arrived and changed a lot of things. It changed a lot of things because sysadmin weren't deploying their operating system on physical individual computers, but on virtual computers in an hypervisor over the physical computers. They make things easier for them. They make things a bit more agile. But for developers, it was more or less the same thing. They develop an application in their laptop, and then they send the application to the sysadmin, to the DevOps, we will say now, and he would put the application on the production environment, and both environments were very different. Laptop, usually with Mac or Windows, production with a Linux server, not the same version of the tooling, and that made things complicated. So when Docker arrived, everybody began to use it. Why Docker? It wasn't the first container engine. Containers have existed in Linux for years and years, because Docker was thought to make developers' life easier. And that was the key of the success. Sysadmin already had containers, but Docker allowed a developer to have containers in their laptop. And that changed things. They could deploy complicated architectures on their laptop very quickly. So I need a WordPress, so I get an image for the front end, a WordPress engine, on some PHP engine, on some web server, MariaDB or MySQL engine with an external disk, boom, 3 lines, and you had your settings. And if it worked on your computer, it worked on production. But if that was true for developers, it changed things. For sysadmin, for DevOps, not really. Because, yeah, you could deploy a WordPress like I told you in last slide, but in production, any sysadmin will ask you to do that. They will need a load balancer, several front-end instances, several database instances, redundant volumes. And that means that for a DevOps, things don't really change with containers. Or even, they were even worse. Because it was then that the trend of microservices arrived. So for a single application, before you had only 1 or 2 containers with microservices, you needed 10, 20 containers. For developers, it was easy. Each small application was a container, easier to develop, easier to make evolve. But for DevOps, it was a nightmare. And that was the reason why they needed an orchestrator. They needed something like Kubernetes. Kubernetes wasn't the first one. People were already doing things like orchestrating containers with things like Mesos, for example, before Kubernetes. Why did Kubernetes become the de facto standard? Yeah, because it was easy. Easy for DevOps, easy for developers. So that made it was only a different approach. If you needed to orchestrate your containers with Mesos, you needed to have a lot of knowledge and skills. With Kubernetes, you could begin to do it in a single evening. And that was one of the reasons why it's so popular. Another one is that it's pushed by Google and by all the other cloud providers in the world right now. So, in 5 minutes, with Kubernetes, you have a master, the brain of your cluster, with all the cluster services, and you have the worker nodes, where you deploy your applications. In the masters, you have a lot of components to control the resources, to make sure that all the applications you have set up to deploy are really deployed. And you have an API server, a stateless module that is the center of your cluster. Everything you need to ask your cluster to do, you ask to the API server. And all the elements communicate with the other elements by the API server. And there is the etcd. The etcd is the brain of your cluster. It's the only stateful component in the master, and you keep the state of your cluster there. If you lose it, your cluster will have no memory, will be useless. In the node, you have some components in order to communicate with Kubernetes master, and you have the pods. The pods are the running unit of Kubernetes. You could think, why the pods and not the container? Because Kubernetes is made to be modular. It's made to be extensible. You can add things to Kubernetes in an easy way. Let's say that you want to add encryption between the internal communication. You could do it 2 ways. You could get every Docker image, add encryption in the Docker image, create a new Docker image with all the communication encrypted, and deploying the new image. But that means that for every release, you are going to have to do the same thing. Or with Kubernetes, you can have in a pod your image and adding another container, a sidecar. And this sidecar is going to manage some aspect for you. For example, getting all the network communication before it gets out of the pod and encrypt everything, or getting logs, or getting metrics. So the idea of having a pod as a running unit is to be able to add modularity, to add sidecars to your application containers. That's another of the keys of the success of Kubernetes. So with Kubernetes, the idea is you are going to define your desired state. You are going to describe the architecture you want to deploy. You aren't deploying anything. You are going to say to your Kubernetes cluster the same thing you will do with another sysadmin. Hey, please deploy me this, and this application, I want it to be in 5 instances, and this one in 2 instances. And if we have a lot of traffic, we can go up to 6 instances. And I need this database to have an external disk of 20 gigabyte. And you describe everything in configuration files, in YAML files, and you give it to Kubernetes. And Kubernetes will implement your desired architecture and will be sure that what you have asked, it's really done. If a pod dies, it's going to put another pod in the place. If traffic arrives and you have tell it to add new instance, it's going to add new instance and to reduce them with the traffic disappears. You are going to be able to explain what architecture you want. And that also means you are going to be able to create easy clones of your cluster. You are going to be able to have pre-production clusters, staging clusters, or developer clusters, developer environments that are really similar to the production. You are going to be able to have also multi-cluster setups. So it's really interesting, yeah, and it's modular, as I told you. You are going to be able to extend your Kubernetes. And there is a huge ecosystem today with lots and lots of things you can add to your cluster. Because Kubernetes, you can modify it a lot of levels. You can modify using the API or extending the API. You can use cluster daemons in order to have new services running on the background, monitoring or adding things to the cluster. You can add new controllers to manage new resources. You can modify a lot of things. So you have a modular system. Here we have Helm, that is a package manager for Kubernetes, something like a Maven or a Gradle or a NPM for Kubernetes. You have Istio, it's a service mesh. I will talk about it in a minute. You have Velero in order to do full backups and restore of your cluster. So you can take the basic cluster, you can deploy your application, and when you need, you can add new functionalities without changing your deployed application. For example, Istio will get you for free things like full monitoring and logs, encrypted communications, point-to-point communication, allowing to say who has the right to communicate with who. You are going to be able to do in a very, very simple way complicated things like rolling upgrades, A/B testing, canary testing. So all that with your Kubernetes cluster only by adding some new module. But the real key to the success of Kubernetes wasn't all that. The real key for me was that you could easily test everything, all the shows I have said, all the other modules in your own computer, in your own laptop. And that's what a game changer. There is a tool, a very nice tool, Minikube, that allows you to deploy a full Kubernetes in your laptop, Windows, Linux, Mac, and it works. So you can deploy your microservices architecture, you can deploy your Istio to do the encryption and the control of communication, to having metrics and logs. You can deploy Velero in order to do full backups of everything, and it works. Well, it works, but it is still your laptop. You are going to deploy half a data center of infrastructure in your laptop. You cannot expect it to be fast or to run as well as you would like. It's a testing setup, it's a learning tool. And that's part of the problem. Lots and lots of tutorials, videos, talks explain how to deploy very complicated architecture And you can do easily with Minikube. You can test them. But how about going into production? And it's there that the problem begins. Let's say that you have deployed your architecture on Minikube, and you have some problems to add. Hey, how about testing the auto-scaling? Hey, how about if we have some backup to do? Yeah, it's a little more difficult, but you can find lots and lots of information. And then, after testing it, you say, hey, I am going to deploy my own Kubernetes. It can be difficult. Well, it isn't really difficult. It can take you an evening. You will have some problems here and there. You will look at the documentation. You will use tools like Kube Spray, Kubeadmin, and you are going to deploy your first cluster in 3 or 4 virtual machines. And it will work. It will work. You are here. And the problem is that you will have a working cluster, but it isn't a production cluster. It's very far from a production cluster. In order to get a production cluster, there are lots and lots of traps, like our old Akbar says. And those traps aren't well documented. There is no central repository of what do you need to do in order to have a production Kubernetes. And they ask for a different skill set. You can be very good to administrate Kubernetes, to deploy things, to put complicated architecture into Kubernetes, and still not being able to install a proper production Kubernetes. And you can be very good in installing a proper production Kubernetes and not be able to administrate it from your needs. The two roles are very different. So I am going to tell you the journey that we have done from having a small Kubernetes to a production Kubernetes to managed Kubernetes services. At OVH, we began with Kubernetes several years ago. We used it before for internal application. So we have some small clusters. They weren't prod ready, but they were for internal application, no problem. Then we did the journey in order to have a production cluster, and we learned a lot of things. And then we did the next journey in order to have a managed Kubernetes service, because we discovered that installing Kubernetes is a different job of using Kubernetes, and most of our customers, they don't need to learn to install a production Kubernetes, as they don't need to build their own servers, and they don't need to put their own servers on a rack. They need to have the infrastructure. If you consider that Kubernetes is the infrastructure, most of our customers only wanted to have a working Kubernetes, and that's the base of a managed Kubernetes service. So, let's begin to travel. The first problem we found was the abstraction. I mean, Kubernetes is almost magical. It does lots and lots of things in an easy way on the background. You say, hey, Kubernetes, I want to deploy that with these conditions, and I want also to add some encryption layer, some logs and metrics, and I also want to add some periodic backup. But you aren't deploying anything. You are making your Santa Claus list. So, in order to implement that, Kubernetes is adding abstraction layer over abstraction layer over abstraction layers. It's creating a lot of layers between the instance where you deploy your application, the network underlying, at what you see. When everything works, it's wonderful. When you have problems, it's way more complicated, because, hey, I have a problem. The application isn't deploying. Why? Well, you need to take your shovel and begin to dig abstraction layer under abstraction layer under abstraction layer. So the first problem we had, and the first skill we had to learn, and everybody who tries to deploy their own Kubernetes should learn, is to navigate these abstraction layers and to be able to find where the problems are. It happens for every kind of problem, deploying problem, network problem. You need to understand the global architecture of Kubernetes, what are the abstraction layers for each aspect, and how you can go deeper in order to find the truth of your problem. Then we have the network. Hey, the network is our business at OVH. And we were surprised. We have a cluster. We thought it wasn't a lot of real traffic, but when we tried to measure, we had all latencies. We have sometimes saturated networks. Why? Well, the problem is that the abstraction layers of the network side are complicated. In the first time, everything is in the network is managed by a network plugin. You have several choices of network plugins, Flannel, Calico, Wave. You can choose them, but at the beginning, most of them are going to do a right job if you configure them well. At the beginning, you have your cluster with a by default network plugin, usually Flannel, with a by default configuration, and the network plugin it's going to configure all the network components in your cluster. It's going to give an IP address to every node. It's going to configure in every node the IP tables in order to do the routing, because all the routing is done with IP tables in the node side to manage live these IP tables. It's going also to define how the cross-node communication is done, what communication must go to the master, and it's going to add an overhead on your network. Then, how do you expose your applications is very important too. By default, most applications are exposed only internally in the cluster with a cluster IP. You can expose it to the outside using something called node port. And node port means that you are opening a port in every one of your nodes and assigning that port to one application, to one service. So when traffic arrives to that node, hey, that's for the service A. We are going to send that internally to the service A, and the service, each service, defines what deployment, what pods are behind that going to answer the request. So there is a new network travel. For each request, there are several requests and response internally. So you are going also to have an overhead there. And if you are using things like Istio, for example, to make the encryption on the fly, or to be sure that this service can communicate with this one, but not with this one, that means that every request, Istio is going to make your service ask to the API server if they have right or not, and then encrypting and sending the traffic. All that means that it is difficult to monitor accurately the traffic in Kubernetes. It is difficult to say if all your network is correctly dimensioned. And it also means that sometimes things aren't working when you think it should be working. And if you add to all that several components are more sensible to network flagging than others. For example, in the master, the link between the API server and the etcd, the brain of the cluster, must be as smooth as possible. Because if you have latency there, you can get some weird problems when the commands from the API server aren't store in the etcd at the right speed, and then you have new commands, and then you're trying to read, but the precedent write wasn't there. You can get some weird states. So you need to understand the underlying network model if you want to get serious about Kubernetes in production. And then, okay, so I have a good cluster. Now I understand more or less how to dig in order to find problems. My network is okay. I can open it to the world. Not really. The slide there was from Cloud Next last year. I was there. The lady at Google presented the slide, and everybody in the room began to laugh. Everybody was, everybody has lived that. Here at the left, you have your first Kubernetes cluster. Here in the right, you have a production cluster. And all those tasks are security things you should do. You should verify before putting your cluster in production. Here we have the things that were the more surprising or important for us. For example, by default, there are a lot of open ports in your Kubernetes, but especially there is the etcd port that is wide open to the world. So if your etcd cluster or instance isn't well configured, you are going to have everybody to directly attack the brain of your cluster. Or the Kubernetes API. There is a funny history with Tesla, and they aren't silly, they are really smart. They had a big problem because the Kubernetes API, by default, it isn't open. There are some rights, but you can install things that make your API indirectly open. So Tesla people had installed a Kubernetes dashboard in the production Kubernetes in order to have some global view, some interesting metrics, some graphical administration tool. And by default, the Kubernetes dashboard opened the API. So they got kidnapped by the API that give the attackers direct access to the working nodes, and they install a crypto mining facility on Tesla production cluster. There is a great postmortem of that. You can Google it, and it was an example of all the problems you have when you install things that modify the Kubernetes API. It's a great thing that you can modify, extend the Kubernetes API. It makes Kubernetes modular, but it also opens lots and lots of risks. So you must be sure that what are you installing and what are the effects in the security. There is also all the CVE that appears every month. Hey, there is a new huge hole in Kubernetes, in the kubelet architecture, in the network model, in the API. So you need to be all the time informed of all the security updates and applying them in a timely manner. And if you don't do it, as Kubernetes is one of the primary targets for hacking today, you are going to get very serious problem fast. And there is the RBAC, the role model. With Kubernetes, you have a role-based model in order to grant permissions, rights, and all that. By default, you have an administrator role and the other role. You should try to really define a good architecture of the roles and the rights in your cluster according to what are you installing, what are your needs. You should have different roles for the cluster administration, for the Kubernetes modules, and for the normal application. You should try, as every time, you should try to have the less permission, the less right possible for each role. Why? Because sometimes hacking an application is easier than hacking a Kubernetes module or directly the API. And if the roles aren't well defined, by hacking the application, you can escalate and gain control from other components or from the full cluster. So the security part isn't complicated. It's the classical security paradigm adapted to Kubernetes. But it is complex. There are lots of things. You need to think about that early in order to be ready to go into production. And especially don't try to rush the security. If you don't think before and you have your production in 1 week, yeah, I should suggest you to delay your production for another 2 weeks in order to really learn and apply all the procedures before opening it to the world. There is the storage, for example. It shouldn't be a problem. Well, it shouldn't. Let me rephrase that. At the beginning of containers, everybody say, containers are for stateless things. And it was easy, and it was good. But, as usual, when a technology begins popular, people wanted to do databases on containers. Why? Yeah, because I would like to have the same database in my laptop that in production, so I want to put it in a container. Hey, but when the container dies, everything is deleted, and you begin with a fresh image. Yeah, so we need some external volumes. And it was the beginning of a big problem. Okay, it gave the containers a lot of new possibility, but you had to associate to every container an external disk. That means that if your container died, you had to be sure that the new container was in the same instance or had access to the same disk. With Kubernetes, things were similar. At the beginning, the idea was having Kubernetes for most of your compute problems, stateless workloads. And then it's wonderful. But people began to say, hey, but I want to put my PostgreSQL, my MongoDB on Kubernetes. But why? You can deploy a MongoDB cluster near your Kubernetes cluster. You can deploy your PostgreSQL cluster near your Kubernetes cluster. Yeah, but I don't want to have to administer 3 different clusters. I want Kubernetes to be my one and only solution. Well, bad news. As usual, when you only have one solution, one hammer, you are going to adapt everything to use your solution. If you have only one hammer, you are going to attack every problem as if it was a nail. But it was the same problem. So people began to build stateful workloads with Kubernetes, and for that, they had to find a way to associate to your Kubernetes clusters external or internal disk in order to store things, to store the stateful loads. The way to do this was to use the PVC, persistent volume claims. So in Kubernetes, you are describing what kind of disk do a pod need. Okay, my MariaDB pod, it needs 40 gigabytes of storage of high speed random access storage, because we are going to write a lot of different places in the disk, and we need to be able to write and read in a concurrent way, so we need also high speed. You describe what you need. And then Kubernetes will try to associate your persistent volume claim to a persistent volume, a true external disk, in order to store, read, and write your data. How Kubernetes does it? Well, when you install a Kubernetes cluster, you are going to define what storage classes you want to use, what kind of storage you want to offer in your to propose in your cluster. So you could say, hey, Kubernetes, you are going to be able to access that huge NFS disk, and you are going to be able to ask chunks of 1 gigabyte. So when you have a persistent volume claim, you are going to use NFS to implement it. Well, if you have used NFS, you know that it isn't the best solution to store a database, but you could do it. You could also define some more sophisticated solution. I am going to use Swift or Ceph or Cinder as a storage. The problem is that by default, the only solution that you have in a new installed cluster is NFS or deploying your own Ceph, Cinder, Swift solution and linking it to your cluster. We at OVH, we were lucky. All our infrastructure is based on OpenStack. So we already have a Ceph file system, we have Cinder over it, and we could propose to our cluster some different disks adapted to many kind of use. But if you are doing it in your side, you need to be sure you are proposing different disk solution, different persistent volume solution adapted to different use case. You are going to need high speed solution for database with concurrent read and write. You are going to need also solution for file storage, maybe sequential storage with you don't need to be so concurrent in read and write, but you need to be able to store bigger volumes. You need to define what architecture storage you are using, and you shouldn't be using the by default solution like using NFS in order to store your database loads. There is also the etcd. I was rather surprised when I installed my first Kubernetes in several virtual machines, and then I saw that the etcd was a single instance, not redundated, not persisted. It was an instance that when you killed it, you lost your cluster. Yeah, the by default install makes your etcd rather vulnerable to every problem. And if you have a problem with it, all your cluster has a problem. So if you have installed your Kubernetes, you need to begin to learn about etcd. You need to begin to learn how it works, how you can install it in a cluster with at least 3 or 5 instances, how you are able to back up and restore it in a timely way. You need to learn about etcd because it is one of the critical points of your cluster. And you should never, ever leave the by default install with a small instance in a corner. But let's say you want to go even further. For example, let's say you are working for a big company and you want to propose different clusters to different internal teams. Or like us, you want to be a managed Kubernetes and to propose one different cluster to every customer. Then you have a whole new set of problems. And the first problem is how you are going to do it in a cost-effective way. Why? Because remember, there is the master. The master, it means at least 1, 2, 3, 5 instances and one etcd that should be a cluster. So that means that for every customer, for every cluster you are deploying, for every one of your internal teams, for every one of our customers, we were going to deploy 5 instances only for the master, and then the workload. That means that we were wasting lots and lots of resources in order to keep these masters alive. And that also means you need to administer, to operate these masters, to be sure that every component is working, to be able to restart any component that fails, you need to operate them. That means instance and people. It isn't cost effective. So I am going to tell you how do we do it. I don't know about our friends at Google or Azure. They have the same problem. I am sure they are using some similar solution in order to make it cost effective. I am going to tell you how do we do it. And if you have several clusters to administer in your company, it is a good way. We have all the information on the open, so you can ask us and we will give you all the links for that. We did something that we call Kubeinception, like the movie. We are running Kubernetes over Kubernetes, or better say, we are running our customers' masters on one of our administration cluster. So we have a Kubernetes admin cluster with a lot of instance, with an etcd correctly redundanted with 3 or with 5 instances, a good backup systems. And then in our nodes, when a customer asks us for a new cluster, we are deploying the master as if it were Kubernetes pods. We are deploying a pod for the API server, a pod for the scheduler, pods for the controller, and then the customer nodes are in their own cloud project at OVH. So we are telling our customers, hey, the master is on us, it's for free. And then you are paying for the nodes, and you have the nodes in your customer console. You can add or remove nodes as you want. We control the master. We tell you that if there is a problem with the master, we are going to deal with it, because our Kubernetes master is going to deal with it. Hey, the controller manager is down. No problem. Our Kubernetes clusters is saying that it is down. It is redeploying it 1 second after. There is no problem about that. We don't need to individually administer our customers' masters. And they are responsible for putting all the architecture in the nodes, installing any plugin, any Istio, Velero, whatever, deploying their application, modifying anything. And for us, that means that we can mutualize the cost and the operation of all those clusters. So we have another customer, same thing. In order to do that, we had to modify the underlying network model. We had to give these pods direct access to the nodes and to the customer etcd. So that means hacking a bit the underlying model. It took some time. If you need the information, we can give you then. And everything was done. Well, not everything. There was still the problem of the etcd. So if we wanted to be serious, we were going also to need 3 instances of etcd for every customer and to administer that. It wasn't the same problem, but the solution was different. We couldn't put etcd on Kubernetes because it didn't really work. But etcd is really nice because you can really well isolate loads from different users. So we had a good experience, a good skill with etcd because we have used it for several projects. We choose to put one big etcd cluster associated to every administration cluster. And on that big cluster, we had physical computers, well-redundant, well-installed with 5 instances, a physical disk, a full backup and restore procedure. And then on that etcd, we added a partition for every one of our customers to store their data. So we had the Kube inception with the mutualized etcd, and it really made things way easier. We went into production on last November. Then we were able to have several hundred of customers in a normal administration cluster. Then we add a second cluster when we had more customers. And we administer only a handful of administration clusters and etcd. And the day-to-day operation is really easy because most of the work is done by Kubernetes itself. Conclusion. Yeah, so Kubernetes is really powerful. It can make things easier for you if you are a developer. It can make things easier for you if you are a DevOps, a sysadmin. It can make also things easier for you from a business point of view because, hey, it's very hype today to have a Kubernetes in production. But you should never forget that there are different roles around Kubernetes. And those roles have different skills and different knowledge needed. You have the Kubernetes operator, the people who install, who do the day-to-day following, the production following, who apply the security patches, who manage the underlying Kubernetes infrastructure. Most of them don't know anything about deploying application in Kubernetes. It's really fun. I have some colleagues that are really, really interested on the installing side of Kubernetes, on all those odd problems I talk, but they have never deployed even a single hello world. There is a different role with different problems. There is the cluster administrator, the people who is going to use the underlying Kubernetes infrastructure in order to build architectures on it. It's going to deploy some extension like Istio. It's going to deploy the workload. It's going to define how are things done, the namespaces in order to isolate some things. He's going to define the role and what each role is doing. He's going to package sometimes application in order to deploy them, to see what of the different packets for an application you find on the internet is the best one. And that's another different skill set. It's a very DevOps role in the good sense. And there is the developer who must know how to put an application into Kubernetes. What are the constraints? You should be able to put your application in containers, to know how to split different things, to be able to describe what kind of scalability setting you need. And you are going to write your Kubernetes files in order to deploy the applications in Kubernetes. And the three roles are complementary. But for most use cases, not all, but for most companies, you don't need really the cluster operator role. Yeah, if your company isn't building their own servers, if your company isn't putting the servers on a rack, if your business isn't installing one by one all the operative systems in your servers, if you are a company using a cloud, you shouldn't be bothering with all the installing, security, administrating part of Kubernetes. You should deal with Kubernetes as a service. And then you should deploy all your workloads on Kubernetes. You should be really good in the Kubernetes administration part, and your developers should be aware of all how they deploy their application on Kubernetes, but you don't need a cluster operator. So in that case, yeah, if you can, use a managed Kubernetes, ideally ours, but anyone, because all the managed Kubernetes work in the same way. There is a certification. The CNCF certification that makes sure that all the Kubernetes are similar. You can deploy the same workloads in any Kubernetes. You can deploy in your Minikube, you can deploy in the Kubernetes you installed last evening, and then when you are ready to go to production, you can deploy the same workload on OVH managed Kubernetes or in any managed Kubernetes for any of our friendly competitors. And it's going to work. That also means you can deploy your solution in different cloud providers. For example, if you are working with Far East, you could deploy in one provider in Europe, one provider in China, another provider maybe in the States, and you are going to deploy the same workloads across all the different managed Kubernetes services. So if installing Kubernetes isn't your business, like if building your servers isn't your business, please look at a managed solution. It will be, I think it will be a very nice way to have a production-ready Kubernetes easily. And if you are in the business on building production Kubernetes, because you are a big company, for example, or you have some strict security concerns, regulation, then please come talk with us and other people who have done it. We love to share and to learn of your experience. And it can help us and you to make everything better. So if you want to try a managed Kubernetes, please send me an email. I will get you some vouchers for hours. And I hope you have learned something. If you have any questions, time is up, but I will be there just after the talk. Don't hesitate to come ask me anything. Thank you very, very much.